Hello, discrete math fans. We're going to try a problem out of the book. This is section 1.3, problem 2. I give you a set, C and D, and they're the same set. They consist of the numbers -3, -2, -1, 1, 2, and 3. And we'll define a relation S from C to D as follows. For every x and y that's in the Cartesian product, C cross D, we're going to say that x comma y is in the relation will mean that 1 over x minus 1 over y is an element of Z. And we'll ask a whole bunch of questions, like, is 2 related to 2? Is -1 related to -1? Is 3 comma 3 in the relation? Is 3 comma -3 in the relation? And then here's a follow-up question that wasn't in the book. Is 4 comma 4 in S, our relation? Then we'll write S as a set of ordered pairs. We'll write down the domain and codomain of S. And then we'll do something we haven't talked about yet, which is we're going to write an arrow diagram for S. All right, so for the solution, part A, 2 is related to 2 because 1/2 minus 1/2 is equal to 0. That's in the integers. -1 is related to -1, and 3 comma 3 is in S for similar reasons. When you plug them in, you will get an integer. However, 3 comma -3 is not in S, because if you plug in 3 and -3 into our expression, we'll get 2/3. That's not an integer. Now the follow-up question, we're going to say that 4 comma 4 is not an element of S. It's really a nonsense question. 4 is not an element of C, so we can't even really ask this question. 4 is not in the domain of the relation. Then, in part B, we write down all the elements that are in the relation. Should look like this. Now, it's important to note that it's easy to see that all the ordered pairs where the two numbers are the same, that's definitely in our relation. But there are other things. You should see that -2, 2, -1, 1, 1, -1, and 2, -2, those are also in our relation because if we plug them into our formula, 1 over x minus 1 over y, we'll get an integer. The domain and codomain of our relation come directly from its definition. The domain of S is the set C, and the codomain of S is the set D. Now, they are the same set, but we kind of want to think of them in different ways. One of them is playing the role of the domain, one of them is playing the role of the codomain. So we'll kind of look at them differently for the purposes of this problem. All right, so up until this point, we haven't talked about arrow diagrams. Let's do that now. What we're going to do is we'll make a picture of the domain and codomain. It'll look like this. Essentially, we just create a set of our numbers, little dots indicating the numbers that are in the set, and label them. So we have our domain and codomain. And then we're going to put in arrows that correspond to the relationships between the elements of the domain and codomain. For example, we know that 1 is related to -1, so we're going to draw an arrow from the number 1 on the left to the number -1 on the right. Something like this. Now we're going to finish the arrow diagram by drawing an arrow between each element of ordered pairs that are in the relation. So our final arrow diagram looks something like this. So we actually have a total of 10 different arrows. That's because there are 10 ordered pairs in our relation. Okay, that's all for now.